Okay, we're going to solve a linear system of equations algebraically, and the first method we're going to use is called the substitution method. So to start with, we've got two relations shown. Label each one with its corresponding equation. Okay, so we'll just do that by y-intercept. So that's negative x plus 6, and then this is y equals 2x minus 9. State the solution to the system. Well, the solution is a point that satisfies both equations, so it lies on both lines. So the solution is 5, 1. Verify that the solution satisfies both equations. Okay, so line 1, the left side is equal to y. The right side is equal to negative x plus 6. Y is 1. This is negative 5. The negative of x plus 6, which is 1. So we know the point 5, 1 is on this line. Now let's check the other line. Oops, so the left side is equal to y. And the right side is equal to 2x minus 9. That's 1. This is 2 times 5 minus 9. 10 minus 9, also 1. So that is a solution that satisfies both relations or both equations. How can we find the solution to a system if a graph is not provided? Graphing both lines can be time-consuming, and sometimes the intersection point is not clear. So we need to know an algebraic way of determining the solution. For the solution, we know the point xy must belong on both lines. In other words, we need to find an x value that produces the same y value for each line. What is an expression for the y value of line number 1? Well, what's that expression? It's negative x plus 6. And what is an expression for the y value? Whoops, wrong way. Of line 2, it's 2x minus 9. For the solution, we know that for one particular x value, the y values are the same. Make the expressions for the y values equal to each other and solve to find out which x value will make the relations have equal y values. So set the two things. Since they're both y, then they must be equal to each other. I'm going to move this x over here, giving me 3x. I'm going to move the negative 9 over there, giving me 15. And at the same time, I'm reversing sides. And we get x equals 5. So we know that an x value of 5 will produce equal y values. So far, we know the solution can be represented as 5, 1. What about, or sorry, 5 comma y. What about the y coordinate? Use the equation for line 1 to find the y value. So y is equal to, what's the expression? Negative x plus 6. Substituting a value of 5 in for x gives us y equals 1. Equation 2, the expression is y equals 2x minus 9. Substituting an x value of 5 gives us y equals, whoops, 10 minus 9, or y equals 1. So it didn't seem to matter which one we used there. As you can see, an x value of 5 resulted in a y value of 1 for both relations. The solution as an ordered pair is 5, 1. Verify this with the solution you stated in part B. So let's go back to part B. Whoops, and there's the solution to the equation, 5, 1. This is known as the substitution method because we can substitute the expression for a variable into the other equation as shown below. The substitution method is called an algebraic method because we use algebra instead of graphs to determine the solution. Alright, here are the steps. We need to isolate the expression for one of the variables in one of the equation, whichever is easiest, by rearranging the equation. So we're going to write the equation as either x equals or y equals. Now in this case, the y is already isolated, so we will see in other examples you may need to rearrange the equation. And hint, what you're looking for is a leading coefficient of 1. We're not looking at this. This wouldn't be a good thing to do. Substitute the expression for the isolated variable, so we know that y is equal to negative x plus 6. We can substitute that into the other equation. Oops. Let me just clean these up. So wherever we see y, we are allowed to write negative x plus 6. So we're going to substitute for y the expression negative x plus 6. We have this equation which we're now going to solve. And then we use the answer from step 3. Once we have solved for one of the variables, we substitute it back into either equation and solve for the remaining variable. So we can use either equation. We've shown that before. And we write the solution to the system as an ordered pair. Very important, right? So in parentheses with a comma in between. And refer to part C for how to verify. Verify the solution in both of the original equations. And the reason you do that is if you made a mistake, then you might, having made a mistake, you'll have a different system and you'll have a solution to the wrong system. Okay, so we verify in both of the original equations, and you can see we did that back here. Okay, substituting in using a left side, right side check. Right, so those are the steps. So you solve for one of the variables, substitute into the other equation, solve for that, solve for the remaining variable, substitute that into one of the equations, get the ordered pair, and then verify the solution. Use the same system to show that you could have used the expression for x instead of y to substitute into the other equation. We're not going to show verification here because, well, we don't need to. We've already verified. So let's start with this equation. I'm going to move the x to the left side where it will become positive, and the y to the right side where it will become negative. So I know that x is equal to negative y plus 6. I'm now going to substitute that into the second equation. So y equals 2. Now instead of x, I write negative y plus 6 minus 9. Y is equal to negative 2y plus 12 minus 9. Okay, we're going to move this over. 3y is equal to 3, and y is equal to 1. We can then substitute into one of the original equations. Let's go back into this one. So y is equal to 2x minus 9. 1 is equal to 2x minus 9. 10 is equal to 2x. X is 5. And the solution is 5, 1. And we've already verified that, so we don't need to show it again. Solve each of the following equations using the substitution method. Verify the solutions algebraically. Also verify graphically for the first one. Okay, so just for communication's sake, I'm going to call this 1, and I'm going to call this 2. So what we're going to do, since 1 is already solved for y, we are going to substitute 2x minus 1 for y in the second equation. Okay, I don't want to put it in here. I'll just end up with 2x minus 1 equals 2x minus 1. So 3x plus 2, now instead of y, we're going to substitute 2x minus 1 equals negative 16. 3x plus 4x minus 2 is negative 16. This will be 7x. Let's add 2 to both sides, is negative 14. So x is negative 2. What's y? Well, we're going to substitute negative 2 for x in equation 1. So y is equal to 2x minus 1. Y is 2 times negative 2 minus 1. Negative 4 minus 1, y is negative 5. So my solution expressed as an ordered pair is negative 2, negative 5. Now we need to verify the solution algebraically. So we're going to, y equals 2x minus 1. So the left side is equal to y. Don't need much space here, right? Which is negative 5. And the right side is 2x minus 1. And those are both the same, so that's good. Oh, it's supposed to be a check mark. And we're now going to do the same thing in equation 2, which is 3x plus 2y. So the left side is 3x plus 2y, and the right side is negative 16, so that's 3 times, alright, let's get the point right, what is it, negative 2, negative 5, so 3 times negative 2 plus 2 times negative 5, which is negative 6 minus 10, which is negative 16, and this is negative 16, so that checks. And we also want to verify this by graphing. Now, in order to graph, I'm going to have to solve this for y. So it's going to be 2y is negative 3x minus 16. Y is negative 3 halves x minus 8. So I'm going to bring up a calculator. So in y1, we're going to graph 2x minus 1. And in y2, it'll be negative 3 halves x minus 8. And let's hit graph. And we're looking for this point. Second calc, number 5 is intersect. I trace to the point and hit enter 3 times. And we get x is negative 2, y is negative 5. So that verifies graphically that that is the solution, which we already knew because we've done it algebraically. Okay, this one. So number 1, number 2. I'm going to solve equation 1. Move my tablet. For x. So x plus 4y is equal to 8. X is equal to negative 4y plus 8. I'm going to substitute, because that's the name of the solution method. I'm going to substitute negative 4y plus 8 for x in the other equation, in equation 2. So wherever I see an x, so here's equation 2, 2y minus x is negative 26. Scroll that down. So 2y minus, now since this is an expression, I'm going to put it in brackets. Negative 4y plus 8 is equal to negative 26. And you notice now we simply have an equation in y. So this is going to be plus 4y minus 8 is negative 26. Add these two together, 6y. Add 8 to both sides. So this will be negative 18, and y is equal to negative 3. I now need to get x. So I think it's easiest, we'll go back into number 1. So in equation 1, x plus 4y equals 8. So what we're going to do at this point is we're going to substitute negative 3 for y in equation 1, which was x plus 4y equals 8. x plus 4y equals 8, x plus 4. So wherever we see y, we can put negative 3 is equal to 8. X minus 12 is equal to 8. So x is equal to 20. And the solution then is 20, comma, negative 3. Now we need to verify that, right? Just because we've solved doesn't mean we found the point. What if we made a mistake? So equation 1 is x plus 4y equals 8. So 20 plus 4 times negative 3 equals, with a question mark, 8. 20 minus 12 equals, with a question mark, 8. 8 equals 8. True. And equation 2 was 2y minus x equals negative 26. 2 times negative 3 minus 20 equals, with a question mark, negative 26. Negative 6 minus 20 equals, we don't want to put an equal sign here because we'd be saying it's equal, we're not sure until now. So now we know that 20, negative 3, that point satisfies, right, makes true both of these equations, and so is a solution to the system. Now, what do we look for here? We're looking for a variable by itself, right? That is with a coefficient of 1. So we're going to solve equation 2 for y. So 3x plus y is 13. Y is equal to negative 3x plus 13. So now that we have an expression for y, we go into the other equation. So we're going to substitute negative 3x plus 13 for y in equation number 1. Well, what's equation 1? 2x minus 3y is negative 28. 2x minus 3 times negative 3x plus 13, that's what we're substituting for y, equals negative 28. 2x, we get here, plus 9x minus 39 equals negative 28. So it'll be 11x. Let's add 39 is 11, and x is equal to 1. And we want to solve for y. We can go into either equation. I think number 2 is easier. So we're going to substitute 1 for x in equation 2. Substitute 1 for x in equation 2, which is 3x plus y equals 13. 3x plus y equals 13. 3 times 1 plus y is 13. Y is equal to 10, giving us the solution 1, 10. Now, that needs to be verified. So we have 2x minus 3y equals negative 28. The left side is 2x minus 3y. The right side is negative 28. And so it's equal to 2 times 1. Minus 3 times 10 is 2 minus 30, which is negative 28. Yes. And equation 2, 3x plus y equals 13. The left side is equal to 3x plus y. Right side equals 13. 3 times, and we just substitute in what we think the point is. And that's also true. So that is the solution to that equation. One more. Again, look for the variable that's by itself. Okay, in other words, that has a coefficient of 1. So we are going to, first step, we're going to solve equation 2 for A. So A will equal negative 2b minus 3. Okay, and that's just moving both the 2b and the 3 to the right-hand side. We're now going to substitute negative 2b minus 3 for A in number 1. So that's 7 times negative 2b minus 3 minus 4b is equal to 6. This is always in brackets, right, because you're going to be multiplying and you want to make sure you apply the distributive law. Negative 14b minus 21 minus 4b equals 6. Negative 18b, and let's add 21 to this side, so that gives me 27. So b is 27 over negative 18, which is, let's see, 9 goes into that, so it'll be negative 3 halves. Okay, we want to solve for A. Well, let's go into here because A is by itself. So we're going to substitute negative 3 halves for B in equation 2. That'll be 2 times negative 3 halves plus A plus 3 equals 0. 2 times negative 3 halves, right? The 2's cancel, so you get negative 3 plus A plus 3 equals 0. 0 plus A equals 0, so A is 0. And we have a solution of 0, negative 3 halves, which we need to verify, right? So 7A minus 4B equals 6. 7A minus 4B equals 6. 7 times 0 minus 4 times negative 3 halves, is that, don't write an equal sign here, is that equal to 6? That's 0. 2, that's 6 equals 6. That's true. And the other equation is 2b plus a plus 3. 2b plus a plus 3 equals 0. 2 times negative 3 halves plus 0 plus 3 equals 0. Now there's a question mark over that because we don't know this is true. Negative 3 plus 0 plus 3 equals 0. 0 equals 0. It is true, and that is the solution. Okay, 0, negative 3 halves. You could do that graphically as well, right? If you wanted to verify one of these afterwards, you could certainly do so. Wow, okay, so 1, 2. All right, let's solve number 1 for x. So first step, solve 1. And notice what I'm doing is just communicating with you here, right? I've numbered these 1 and 2, and I'm saying I'm solving 1 for x. So that's 2y plus 10. We're going to substitute. Basically what we're saying is x and 2y plus 10 are the same thing, right? So we're going to substitute 2y plus 10 for x in equation 2. It has to be the other equation. If you stick it in here, you'll just end up with 0 equals 0, which, while true, isn't really very helpful. So 0.2 times 2y plus 10. This is always in brackets, right? You always put that expression in brackets. Minus 0.3y equals 0.8. 0.4y plus 2 minus 0.3y is equal to 0.8. Point for that, 0.1y equals, and we're going to subtract, so it'll be negative 1.2, and divide both sides by 0.1 or multiply both sides by 10. Y is equal to negative 12. So substitute negative 12 for y in, well, let's go with number 1. Oops, no, there's no y there, that's just x minus 10. So x minus 10 is equal to negative 24. Add 10 to both sides. X is negative 14. And we have negative 14, negative 12 as the solution for your consideration. So x minus 10 equals 2y. Negative 14 minus 10 equals, put a question mark over there, right? We don't know that this is true. Negative 24 equals negative 24. Okay, it is true. 0.2x minus 0.3y is 0.8. 0.2 times negative 14 minus 0.3 times negative 12. And here's the question. Is that equal to 0.8? All right, what do we get here? Negative 2.8 plus 3.6. Is that equal to 0.8? 0.8 equals 0.8. Yes, it is. It's true. And this is the solution. I don't know if there's anything else on this page. For application questions, define your variables. What does each variable represent? So you can do that in a diagram, you can do that with a table, you can do that with a let statement. Write a system of 2 linear equations. Solve the system, and then write a sentence that explains your solution. All right, so let's do a few. A rectangle has a length that is 4 centimeters more than twice its width. Okay, so here's a rectangle. And this is the length. This is the width. A rectangle has a length that is 4 centimeters, so the length is 4 centimeters more than twice its width, right? 4 more than twice the width. If the perimeter of the rectangle is 20, so the perimeter is 2L plus 2W equals 23. And that's equation 2. So we have our system of equations. So I've defined my variables, right, simply by drawing a diagram and saying here's the width, here's the length. I've developed my system of equations. I'm now going to substitute 2W plus 4 for L in equation 2, right? Because this is already in a perfect substitution. L equals, okay, 2 times 2W plus 4, right? Because that's L. Wherever we see L, we can write 2W plus 4. Plus 2W equals 23. So we're going to solve for W. 4W plus 8 plus 2W equals 23. 6W equals, and we're going to subtract 15. W is 15 over 6. All right, what goes into 15 is 6. So 3 does. 5 over 2. So we want to get L. And so we're going to substitute 5 over 2 for W in equation 1. So L is equal to 2 times 5 halves plus 4. L is equal to 5 plus 4, or L is equal to 9. Now for the verification, go back to the words. A rectangle has a length that is 4 centimeters more than twice the width. Okay, so forget everything you're looking at. Twice the width, well, that's 2.5. Twice the width is 5, and 4 centimeters more than 5 is 9. So a rectangle has a length, so that checks that L equals 9. If the perimeter is 23, so the perimeter is 9 plus 9, which is 18, plus 2.5 plus 2.5, which is 23. So that also checks. So what I do when I check back is I go back into the original wording and just read this. I don't look at my equations. And then we write a sentence. The rectangle has a width of 2.5 centimeters and a length of 9 centimeters. Right? Now, if this had been like 2/3, I wouldn't say 0.67, or I wouldn't round this. Okay, I would leave this as 2/3 of a centimeter. Oh, and one other thing I think is when you're listing your ordered pairs, you do so in alphabetical order, right? So when we were solving for A, B here, and I would express the ordered pair as the A and then the B. Sam invested a total of $15,000. He put part of it in a term deposit that paid 4% per annum, and the remainder in a treasury bill that paid 5% per annum. After 1 year, the total interest was $690. Algebraically determine the amount Sam invested at each rate. So we could do this with a let statement, right? We could say let x be the amount, etc. Or we can make a little table here if we like. So term deposit, T-bill. Okay, so the amount, well, let's call them X and Y. And what do we know? Well, we know that X plus Y is 15,000, right? The total amount invested is 15,000. This will be interest. And interest is, so the term deposit paid 4%, so 0.04, 4% of X. And this is 5% of Y, and that's a total of $690. Really, we have our equations here, right? We have X plus Y is equal to 15,000. Right? We could legitimately say let X be the amount invested in the term deposit, let Y be the amount invested in the T-bill, or we could use T and B or D and B, doesn't matter. And here's my other equation, 0.04x plus 0.05y equals 690. So I'm going to solve this equation for one of the variables. Solve 1 for, let's solve for y. So x plus y is equal to 15,000. Y is equal to 15,000 minus x. Seems it's not a line. Well, it is a line, but it's not. We're not doing it as a line. I'm going to write it as 15,000 minus x, not negative x plus 15,000. We're going to substitute 15,000 minus x for y in number 2. So 0.04x plus 0.05 times 15,000 minus x equals 690. 0.04x plus what's 0.05 times 15,000? 0.05 times 15, 1, 2, 3, 750. Minus 0.05x equals 690. So this will be negative 0.01x equals, right? So 0.04 minus 0.05. We're going to subtract this, so it'll be negative 60. So x, multiply both sides by negative 100, right? Move the decimal over. X equals 6,000. And then we know that y is 9,000. So what's this, Sam again? So Sam invested $6,000 in the term deposit. 6,000, we need some units on it, right? In the term deposit. Deposit. And $9,000 in the treasury bill. Okay, when I go to check this, I'm going back up to here. So Sam invested a total of $15,000. 6,000 and 9,000 is 15,000. Put part of it in a term deposit. So that was 6,000. That paid 4% interest. And you put part of it, 9,000, oops, in a T-bill that paid 5% interest. And the total interest was $690. So working with the calculator and the words here has verified that this is in fact the solution to the equation. And we're done. Okay, and I'll have some answers to this posted up separately for you for page 163.